Welcome to part 2 of how to use the periodic table. In our first video, we spent a lot of time with protons, neutrons, and mass. But we didn't spend much time talking about electrons. So we're going to pick up with the electrons and what we can learn about electrons from the periodic table. The periodic table is divided into rows and columns, and both of those can give us different pieces of information about electrons. The rows, which go across, so this row, lithium's at the beginning of a row, sodium, potassium, rubidium's row, cesium, francium. Each of those rows is called a period, and each period represents a different electron shell. So hydrogen and helium, they only have one shell. They have one layer of electrons, but all of the elements in this row have two. All the elements in this period have three, 4, 5, 6, 7. So you can tell how many electron shells are in that element based on its period on the periodic table. Now, there's another division about electrons. Not all electrons are the same. There are some electrons that are more interesting than others. These are the valence electrons, and the word valence simply means they are on the outermost layer of electrons. They're on the outermost shell. And we can find out how many valence electrons an element has based on where it is on the periodic table. That is tied to its group. Groups are the columns that go up and down. So we have, as you can see across the top, 18 columns on the periodic table, and some of those have information about valence electrons. Every element in this column has one valence electron. Every element in this column has two valence electrons. Now, this group that we go to from 3 to 12, they kind of change the rules a little bit. And that's okay, we can deal with that. But they don't add new electrons to the outside of their valence shells. They add it to the inside. So these guys technically have the same number of valence electrons as this group. So all of these have two valence electrons. We'll talk a little bit more about why the metals in this middle section are strange. But for now, we're just going to say that they have two valence electrons, just like this group. So then we jump across the transition metals to group 13, boron's group. These guys have 3 valence electrons, 4 valence electrons in carbon's group, 5 valence electrons in nitrogen's group, 6 in oxygen's, 7 in fluorine. And finally, the noble gases, helium's group, have 8 valence electrons. We're going to spend some time talking about more valence electrons in depth later. Now, so we can tell how many shells there are based on what period it is, and how many valence electrons are in that outermost shell based on what row it is. So let's look at iodine. Iodine is in period 5, so it has 5 shells of electrons, and it is in fluorine's group, so it has 7 valence electrons in that outermost shell. We can get that information based on where it is on the periodic table. Now there's a few things that are a little weird. This block down here is a little weird. If we follow the numbers, though, we can kind of get a hint about what's going on. We have 56, then instead of this being 57, this guy is 57, and it goes all the way across to 71, and then it goes back here. So this is a little insert. This is really just for our convenience. If we made the periodic table the same way by putting this in here, it would be super, super long, and it would be kind of inconvenient to use. So this is just a convenient little way to move parts of the periodic table so that we can fit it on one sheet of paper. That's really what this is about. And these are called the lanthanides and the actinides. And we don't need to really go over that, just so you know that's an interesting thing about the periodic table. There's another interesting thing about the periodic table, and this is not true of the ones that I handed out to you in class, but many periodic tables allow you or give you the information of whether the element is a solid, liquid, or gas at room temperature. On this particular periodic table, everything that is blue, bromine and mercury, is a liquid at room temperature. Everything that is black is a solid at room temperature, and everything that is red is a gas at room temperature. So some periodic tables give you a little bit more information. Now, of course, if you change the temperatures, you can change those into solids, liquids, and gas by melting them or boiling them. So those can all change. That is it for our periodic table part 2. I hope this has been helpful. Struggle well.